Welcome back to Solving the Vigenere Family Ciphers, Part 2. Jumping right into practice cipher V4, we have a Gronsfeld crypt using the Vigenere table. V4, Gronsfeld, shell tells a hairy tale. Hint word, around. The methods of attack that work on the Vigenere family also work on Gronsfeld. That is, we can place a hint or probable word. Or we can find the correct period, then determine the amount of Caesar shifts for each group of letters for that period. We can either manually check the potential period lengths graphically to see if they match the normal English distribution. Or we can use the Koziski test. With the Koziski test, we look for pairs or triplets of letters that appear more than once in the cipher, find the distances between them, and look for factors of the distances that meet our guidelines. Message length is period times 10 to 15. With Gronsfeld, though, we have to take a different approach in placing the hint or probable word. Since Gronsfeld uses a numeric key, we can't look for an English keyword or phrase. However, because there are only 10 alphabets, the most any given letter can be shifted by is 9. And we can use this as a weakness. Say we have the crypt JLJC and the hint cat. Testing the first 3 letters. J minus C is 9 minus 2 is 7. L minus A is 11 minus 0 is 11. J minus T is 9 minus 19 is minus 10. 26 minus 10 is 16. The second and third letters have shifts outside of our acceptable range. So this is a mismatch for our hint placement. Trying the next 3 letters. L minus C is 11 minus 2 is 9. J minus A is 9 minus 0 is 9. C minus T is 2 minus 19 is minus 17. 26 minus 17 is 9. Our key was 999, and our plain text was a cat. So the first method for placing the hint word is to just subtract the numeric values of the hint from the numeric values of the cipher letters, and only accept candidates where all of the differences lie between 0 and 9. That's actually a little clunky, though. A slightly streamlined manual approach is to shift each letter in the hint by 9 to create an alphabetic range. Using V4, our hint is around. Shifting each letter, A plus 9 is J, R plus 9 is A, O plus 9 is X, and our other ranges are U to D, N to W, and D to M. Okay, we now have acceptable ranges for each of our hint word letters, so we can try placing them in the message. Starting with position 1 in our crypt, the placement fails because Q is outside the range A through J for hint letter A. Position 2, A passes, but J fails for R through A. Position 3, J passes, but H fails. Continuing on, we eventually get to position 57. I is within the A to J range. U is within R to A. The second U is within O to X. V is within U to D. R is within N to W. And F is within D to M. We now have a working candidate placement. Subtracting out our hint letters from our candidate letters, we get a potential key. I minus A is 8 minus 0 is 8. U minus R is 20 minus 17 is 3. U minus O is 20 minus 14 is 6. V minus U is 21 minus 20 is 1. R minus N is 17 minus 13 is 4. F minus D is 5 minus 3 is 2. There's no repetition of the digits, so the key is at least as long as the hint word. Assuming the key is 6 digits long for now, take the position of the hint word candidate, 57, and calculate mod 6. 57 divided by 6 is 9, with the remainder of 3, or 57 mod 6 is 3. Since remainder 0 represents position 1 in our message, we need to subtract 1 from the remainder, then shift that number of places to the right. That is, shift the key 2 places to the right. 428361 is our adjusted true key, if the key width is actually 6. Following the instructions for deciphering Gronsfeld ciphers as given in episode 12, using our candidate key 428361, we get: my beard grows down to my toes, I never wears no clothes, I wraps my hair around my bear, and down the road I goes. And we're done. To recap for Gronsfeld, Gronsfeld can use the tables for Vigenere, Variant, or Beaufort as desired. We just use the first 10 rows and change the left column index to the digits 0 through 9. Period testing and the Kaczynski test both work exactly the same way with Gronsfeld. The only real difference is in placing the hint word. When we do this, we need to find the differences between the cipher text letters and the hint word letters and ensure that the differences for each letter pair are between 0 and 9. A simplified method for this is to shift each hint word letter 9 places to the right and create an alphabetic range for the hint, such as between A and J or S and B. Once a candidate position is found for the hint, calculate the actual numeric differences to get the key. Shift the key number as necessary to find the correct starting digit, and then try deciphering the message to see what you get. That's it for now. See you at the next drop point. Got questions, comments, or suggestions? Leave them in the comments below. Enjoyed this video? Then I encourage you to hit the like button and subscribe to this channel. If you want to show further support, you can join us over at the Black Chamber Patreon page, where you can get access to more how-to videos and PDFs on solving the cipher types covered here, additional crypts to solve, and more. Links pinned in the comments below. See you at the next drop point.